So all of our work that we've been building up through this entire section, learning how to factor, then solve quadratics, let's go through an application problem, somewhat of a simple one, but to give you an idea of how this is used and why we use it. So let's say, for example, that I'm standing on top of a building and I have one of my favorite Hot Wheels that my kids play, or a ball. We're doing dude perfect. And what we're gonna do is we're gonna throw an object off of the ceiling, off of the roof, and want to know at what point does it hit the ground? At what time does it hit the ground? And this situation can be modeled in a quadratic that we're familiar with. And it's modeled in the quadratic where the height at any particular time is modeled by negative 16t squared plus 48t plus 160. And I want to find out at what point does my height equal 0. So I'm going to rewrite this equation. So I have 0 equals minus 16t squared plus 48t plus 160. I have a standard form of quadratic. My variable is t, so let's factor this out. Well, the first thing I notice is that I can factor out a term first. So let's factor out a negative 16. And then what's left? T squared minus 3t minus 10. Step 2, well, I'm still factoring. That's right. I have to factor until I'm completely factored. Factors of 10 to make a 3. That looks like a positive 5. Nope, a negative 5 and a positive 2. So there's my complete factorizations. From there, we use a zero product, which means that for this to be true, one of these factors has to equal 0. Well, 16 is there's no term in there. I can't add a 0, so I'll look at that one. T plus 2 equals 0, and t minus 5 equals 0. Solve for t. T equals a negative 2, and t equals a 5. So there are my two solutions. My solution set then incorporates negative 2 and 5. And I'm done. That is, if I didn't read the question. The question asked me at what point, how many seconds will it take for this object to hit the ground once I throw it from the roof? Well, a time equals negative 2 seconds doesn't make sense. It doesn't fit. Although the math works, it doesn't fit our reality because we can't go backwards in time. We can always go forwards in time. And so then we're going to only accept our positive result, which tells me then that the solution is 5 seconds, or where the units were in time. So that's one application problem of why this process, why we do it, and how we can start to solve it.